In this video, we'll be talking about reflecting functions, specifically quadratic functions. In the last lesson, we learned of translating functions, which is our shifts, our left, right, up, down. So before we start, we're going to have a definition. Make sure you please have your heading on your note sheet. The definition for a reflection is a transformation. A transformation where an object is flipped over a line, creating a mirror image. So when we were shifting, we had an object move left, right, up, down, and to show that we would be adding and subtracting either to the x value or to the end of the function, adding or subtracting. Here we're going to see what happens when we are reflecting. So our directions we're going to start off with would be sketch each quadratic function. Sketch each quadratic function. And state the vertex. So the same format as our notes on shifting functions. We're going to look at the graphs first and then try to come up with our rules. So for example A, can you write y equals x plus 4 squared? This is going to be our original function. So I'm going to make a little sketch of my graph. XY. We learned in the last lesson that if you have the function y equals x squared and then you change it to y plus 4 inside, that just means you're shifting 4 units to the left. So we're going to go 4 units to the left, and that is going to be our vertex. And just to make sure, I'm going to check on my calculator. I'm going to go to y equals, and I'm going to type in parentheses x plus 4 squared, and our graph. Yep, it's over here, and I'm just going to center my table. So I'm going to go to my table and move it until my top and bottom y's match. And my vertex will be right in the center, -4, 0. So I'm going to go ahead and draw my parabola here. So this is going to be the original that I'm starting off with. Now I'm going to make a little change. So for example, B, I'm just going to throw a negative next to the x. So my equation is going to be y equals plus 4 squared. So notice where the negative is. It's right attached to the x. So we're going to make a sketch of our x and y. I'm going to rely on my calculator for this since this is the first time we're doing this. So we have an x and a y. I'll label the vertex of this in a minute. So I'm going to go in my calculator, go to y equals, and I'm going to put that little negative next to my x. If I look at my graph, notice now it's on the other side. So it flipped over. It was on the left side, now it's on the right side. So I just want to make sure I have my vertex right. To the bottom, there's a 9 and a 9. So my vertex is now 4, 0. So I'm going to go to 4, 0, 1, 2, 3, 4, and put a point. That is my new vertex. Probably should be a little bit like this. So the vertex of this was -4, 0. So we're going to write vertex -4, 0. Over here, the vertex becomes 4, 0. So we're going to write vertex 4, 0. So I want you to notice that when we reflect it over the y-axis, your x value changes. So I'm going to draw a little arrow here. And just write reflect over y-axis. So again, when we're reflecting over the y-axis, the coordinates, the x value changes. Now we're going to do some examples reflecting over the x-axis. So I'm going to change this to example D and example. All right. So the first equation I'm going to write is y equals x squared. So this is going to be starting. Go ahead and graph that by making my x and y axis. Based on the previous lesson, we learned that if we have plus 1 added to the end of a function, that means we are going up 1 for the vertex. So our vertex should be here, but I just want to double check. So I'm going to go to y equals and type in x squared plus 1. See where my vertex is. Moving my table. 10 and 10 matching, so my vertex should be 0, 1. Just right there, so I'm going to go ahead and draw that. So this is going to be my original. Now what I'm going to do is I'm going to put a negative in front of this whole function. So for example, d, I'm going to write y equals negative, and then I'm going to put that old function in parentheses plus 1. So you probably can guess what happens when we have a negative attached to the x. It flipped over the y-axis. When we have a negative in front of everything, we hope that it's going to reflect over the x-axis. So I'm going to draw my sketch. See if we're right. X, Y. I'm going to go to my calculator and type that in. So I have negative parentheses, x squared plus 1 squared. Oops, no squared. Let's get rid of that square. And if I hit graph, notice it was above, now it's below. And just to make sure I have my correct vertex, matching y's, which means the vertex in the middle, so 0, negative 1. So 0, negative 1 is going to be my vertex, and it goes upside down. So I'm going to have us write the vertex like we did above. So if you notice over here, our vertex was 0, 1. Over here, though, our vertex is 0, negative 1. So it changed the y value to the opposite. Can you do one more thing for me? We're going to draw a little line and write reflect over the x-axis. Reflect over the x-axis. So again, when you are reflecting over the y-axis, your x values are changing. It's flipping over from left to right. If you're going to reflect over the x-axis, the negative is in front of everything and your y values change. So we're going to summarize a rule and apply it to equations. So I'm going to take this off. Just like on our last notes, we're going to write rules apply to all functions. Rules that apply to all functions. And I'm going to throw in f of x here, because last time we were doing y equals, f of x will be just all of our functions. So we've got two rules here. If we have negative f of x, that means we put a negative in front of everything, and it's going to reflect over the x-axis. So can you write reflects over the x-axis? Reflects over the x-axis. And you're going to notice that your function just gets multiplied by negative 1. So I'm going to put multiply the function by negative 1. Multiply the function by negative 1. Our y values change in the graph, but when we're changing the equations, which we'll apply in a minute, we're going to multiply everything in there by negative 1. Our second rule, if we have f of negative x, that means we are changing the x's. If you think about it, if we change the x values, it's going to flip over the y-axis. So can you write reflects over the y-axis. So that means you're making all the x's opposites. Well, what do we do with that? We're going to multiply all the x's by negative 1. So can you write in parentheses, multiply x's by negative 1. So now we're going to do some examples of equations. So we've seen what it looks like. I'll show you again. When we're reflecting over the y-axis, notice we put a negative next to the x, and it changed the x value. When we're reflecting over the x-axis, we put a negative in front of the whole function. It flipped over, it changed the y value. So now if we talk about equations, can you write equations of reflected functions? Equations of reflected functions. And we're going to do 4 examples. So this is going to be example E. So we have 2 parts. So can you write if f of x equals x squared minus 6x plus 5, determine a formula that we're going to have 2 parts. So part 1, which I'll call the little I, I'm going to write reflects f of x over the y-axis. Reflects f of x over the y-axis. And then part 2 is going to be the same thing, but we're going to reflect over the x-axis. So can you write for 2, reflects f of x over the x-axis. So if we want our equation that reflects over the y-axis, if you look at your rule, if we're reflecting over the y-axis, we're doing f of negative x. So we're going to do f of negative x. And what that means is we're changing every x to negative x. So if we look at our formula, instead of x squared, our new equation is going to be negative x in parentheses squared. Instead of minus 6 times x, it's going to be minus 6 times negative x, and then plus 5. So again, if we're reflecting over the y-axis, that would be this rule. We're doing f of negative x, which means we're changing every x multiplied by negative 1. So that becomes negatives. So here's our new equation. We have f of negative x equals, if we simplify this, negative x times negative x is just x squared, so it really doesn't change from the original. Negative 6 times negative x is a positive 6x, so that will change. And our 5 stays the same. So notice when we're reflecting over the y-axis, the only thing that changed was the middle term. There's our equation. If we're reflecting over the x-axis, though, a little different. If we're reflecting over the x-axis, this is what we're doing, f of negative f of x. So negative f of x. And what we're doing is multiplying the function by negative 1. So this one's a little easier. So all I have to do is take a negative in front of the function and put it in parentheses. So I'm going to bring down my original, x squared minus 6x plus 5. To simplify, I'm just going to distribute that negative 1. So I have f of negative x equals, we don't want to call this f of x equals because we changed the original. So now I distribute. The first term becomes negative x squared. The second term becomes plus 6x. And the third term becomes minus 5. Notice all the signs change when we reflect it over the x-axis. So here's our new equation. 2 more examples and then we're done. I'm going to grab a new marker just because mine's faded out a little bit. We're going to do example F. And you write if f of x equals, I'll move this up a little bit. If f of x equals 2x squared minus 3x plus 8. What is the equation? What is the equation if f of x is reflected over the x-axis? So a lot of words, but short work. So if f of x is this original function, what is the equation if f of x is reflected over the x-axis? If you're reflecting it over the x-axis, I'm going to bring down my rules. We are doing f negative f of x, which means we're multiplying the whole function by -1. So I'm going to write negative f of x. And what this means is we want the whole equation to be negative. So we're going to take everything and put it in parentheses with a negative in the front. So we're going to bring down the 2x squared minus 3x plus 8. Now to simplify it, I just distribute. So I'm going to write f of negative x equals. Notice every term is going to change. So we have negative 2x squared plus 3x minus 8. There's our equation. Last one, example G. Can you write after a reflection, in the y-axis, the quadratic function g of x equals 4x squared minus 7x plus 2. I'm sorry about all the writing. So g of x equals 4x squared minus 7x plus 2 would have what equation? Last part. Okay, so we're reflecting over the y-axis. If you look at the top of your notes, I'll bring these down for a second. Reflecting over the y-axis means we're doing f of negative x, so you're changing every x. So if you think about it, reflecting over the x-axis, you're changing the x. Reflecting over the x-axis, you're changing the y, which is the whole equation. So now we're really doing f of negative x, which means we're going to change, g of x. Make sure you don't make the same mistake I did. That should be g of x. We are changing every x to negative x. So instead of 4 times x squared, it's going to be 4 times negative x squared. Instead of minus 7 times x, it's minus 7 times negative x. And then we bring down the plus 2. Now we're going to simplify this by getting rid of some of these parentheses. So I have g of negative x equals. Notice we're not writing g of x because this was the original, and now we're changing it. Well, negative x times negative x is just x squared, so this still stays as 4x squared. You don't do 4 times this first, you do the exponent first. Negative 7 times negative x becomes positive 7x, and then we still have the plus 2. So notice again, you're only changing the middle term. This is our new equation. Please make sure you submit a picture of these notes into Canvas to get credit for your work.